Hi, welcome to my video on my new unit on log differentiation. This is the first video in that unit, and the video is going to be the steps in log differentiation. The steps that I'm going to use in log differentiation are: number one, do the ln of each side of the equation. Number two, use the ln rules or log rules. I got logged here, but you can also say ln on the right side. Do the derivative of each side. And number four, solve for y prime or dy dx. dy dx is the derivative of y in terms of x, but it's called y prime. So here we go. Find y prime if off each side by, we're going to do the same one twice, but I'm going to do it to compare. I'm going to do it by the normal derivative, and then I'm going to do it using the log differentiation. So if I were to do this equation by the normal derivative, I would do d dx on each side. So d dx is, we're doing the derivative of y and the derivative of each side by in terms of x. So we do d dx. Now I change my d dx to dy dx and d dy. And I always like to show this step until we get really used to it. Just something I keep showing over and over and over, because we're going to need that when we do related rates and we do the other units that we got to do. So what happens that d dx, I change it to dy over dx, d over dy. Notice the dy's cancel out and leaves me with this. So that means I have a dy dx. So the derivative of y, the derivative of y in terms of y is like d dx. Pretend that's an x and that's an x. The derivative would be, derivative of y in terms of y would be a 1. Now we have a derivative here. This is d dx on this x. We have the power rule, so the 3 goes in front. Decrease the 3 by 1. And we also have the chain rule. This is the inside function. So we have the derivative of 6x plus 7, and derivative of 6x is 6. The derivative of a constant is 0. So that leaves us with dy dx. And right here we have an 18 6x plus 7 squared. And that's also, dy dx is also the same as what we call y prime, just another name. Okay, now what about if we want to do this by the log rule? Again, the power rule is one way to do it, but I only use the log rule, and I'll show you in the next video when to use the log rule, but I want to show it to you now. So if I want to do this by logs, I will do the ln of each side, ln. So we do the ln of each side. So when you do logarithmic definition, you do the log of each side. And now we change, because we have a ln, then this is a power. So what we have is, if you think about it, we have the ln of x to the a. So that's a ln x. The exponent of the x moves in front. So that means that the 3 will move, power of 3 will move in front of the ln. Okay, now we will do the derivative of each side. So we do d dx on the ln y, and we'll do d dx on 3 ln 6x plus 7. So the d dx, we're going to do the same as right here. d dx is dy dx d dy ln y, and we can leave this alone, just rewrite this. I just wanted to rewrite d dx as dy over dx times d over dy. So we just keep the right side as it is. And so that gives us dy dx. So the d dy on ln y, so the derivative of ln y is 1 over y, and the derivative of y is 1. So that completes that step. And we have the derivative here, that's a constant. So that the constant, 3, goes in front. And we got d dx on this right here. So the ln of 6x plus 7 is 1 over 6x plus 7. And we got the chain rule. Derivative of the inside is a 6. So that gives us, if we dy dx 1 over y equals 18 over 6x plus 7. And what we have here is, now we have that completed, so we got 1 over y here. So we're going to multiply each side by y. So when you multiply this side by y, the y disappears, so you get y prime dx. So if I go y times that and y times that, so I have the y, 1 over y times y cancels out, and I get 18 y and 6x plus 7. So dy dx. And now we change y. Y is 6x plus 7 cubed, so 18 times 6x plus 7 cubed all over 6x plus 7. So we get dy dx. So that's the power of 1, that's a 3. When we divide like basis, exponentials, we subtract it. So 3 subtract 1, we get 18 6x plus 7 squared. And that's y prime. And we have, as you notice, the same answer here as we heard, but I did the log rules going down through here. So notice using the log on this will be a little bit longer than the straightforward one, the normal way, but I had to show you using the logarithmic differentiation. That's what this is about. Okay, so let's do another one. Now we have a second one. Find y prime by. And here we're going to do, notice the two of these are the same. We're going to do the first one by normal, and we're going to do the second one by logarithmic differentiation. So let's do the normal way first. So the normal way would be to do the derivative of each side. So we got d dx on the y. So we do d dx of each side. Now I could do this faster, but let's take our time. So we do the d dx of each side. And notice now that we have, okay, let's take care of this. This is still dy dx times d dy with the y. So I change d dx to dy dx over d dy. The dy's cancels out and brings it back to that d over dx. There's the y. Now we're doing the derivative, and notice that this is a f and a g. This is the derivative of a product. So the derivative of a product is f prime g. F times g derivative prime is derivative of f times g plus f derivative of g. So that brings us to, we're going to do the derivative of product rule. So I'm going to write that down as d dx on the x squared and times, so we're going to do the derivative of, leave the tan alone. So that's the f and that's the g. Plus we got x squared and we got d dx on tan x. So there's derivative of f times g, and this is f times the derivative of g. So again, to simplify this, dy dx, the derivative of y in terms of y is just a 1. So let's continue here. So the derivative of x squared is 2x. We have the tan x, leave it alone. Here we have an x squared, and d dx on tan x, the derivative of tan is, if you have it memorized, is secant squared x. So that comes out to be, as is here is good. We could call that dy dx, but that's just times 1, so it's just dy dx, or I could just say that's a y prime, writing down the same statement again. Because I said y prime instead of dy dx. Remember, dy dx is the same as y prime. So that's doing it normal with doing the derivative of each side in terms of x. Okay, so what about if we want to show how to do this one in terms of logarithmic? So if I were going to use logs on this, I would do the ln of each side. Okay, that's done. So we get the log of each side done. Now, according to the log rules of ln, this is the ln of a product, and let me explain. Let's go over here. So if I had the ln of a plus b, so that would be the ln of a plus the ln of b. Logs are exponents. So the exponent rules, when you multiply, you add. So the ln of a product is the addition. So that means we have the ln of x squared plus the ln of tan x. So that's a product. So the ln of a product is the sum of the lns. And we're doing log rules, so ln y, because that's a power, so the ln of x squared is 2 ln x. Okay, so we have just a little tiny rule that we have to obey. Now we have the ln straightened out, so I'll do the derivative of each side. So we're going to do d dx of the ln y, and we're going to do the derivative of each part, so d dx of 2 ln x plus d dx of ln tan x. So we did the d dx of the left side and of the right side, but I put it in through both of them. Okay, so that changes. D dx, we have a y here, so we have dy dx times d over dy ln y, and we have a constant here, so we can I'm not going to do this, I just wrote that out. I'm not going to do the derivative yet, so I'm just going to rewrite this again. I just wanted to change d dx to dy dx over d dy, and I'll do the derivative in the next step. Okay, here we go. And so what do we have? We have dy dx, so d dy on ln y, so that's, if it was ln x, it'd be 1 over x, so it's derivative in terms of y, same as in x, so that's 1 over y, and the derivative of y is a 1, because you use your chain rule, because that's a y, derivative of y is 1, same as derivative of x is a 1. Now we have a constant, so the constant goes to front. So d dx on ln x is 1 over x. And we have the derivative again of ln tan x. So that's derivative of ln is 1 over the function, tan x. And the derivative of tan is secant squared, because this is a chain rule. So the derivative of ln is 1 over the function, and the derivative of the inside function, which is tan, which is secant squared. So I want to, without writing all this down through here, I want to simplify this part of the expression here. I want to simplify this part here. So let me write this down. This is 1 over y. So 2 times 1 over x is 2 over x. That's done. Now let's go over here and simplify this. 1 over tan is cot. And secant. So notice we got cot and secant. So but cot is cos x over sin x. And secant is 1 over cos. So that's 1 over cos x being squared. So what we have is that 1 times 1 is 1, and cos x times cos x is cos squared x. And now notice we're multiplying. We have to simplify. So the cos cancels out, the square cancels out. So that's a 1, that's a 1. Oh, that's a, when I cancel, I got cos x there. So that's 1 over sin x cos x. So I'm going to just leave it like that for a second, and we'll keep going. Now, I could put this as 1 over cos, 1 over sin times 1 over cos, and have cosecant and secant, but I left it in terms of sin and cos because I have the 1 over y here got to be simplified. So I multiply both sides by y because I got a 1 over y here. I could have just, okay, let me explain. What I could have done is said that's 1 over y here, so I'll move that over here, multiply, but I'm multiplying each side by y, so the y's cancel out, so that's why I get a 1, so that gives me dy dx here. So 1 over y goes to here because I multiply both sides by y. So there's my y there. So again, I'll write this down, just not take a shortcut. Okay. Now, dy dx, and another name for y, when you look up here, y is x squared tan x. So when we do that, we go y prime, dy dx, sorry, y prime dy dx equals. Now, the tan, I'm going to multiply the distributed tan in through here, because you notice when I did this, I have it as a plus here. So I'm going to multiply x squared tan x by both of these expressions. So x squared tan x times 2 over x, x squared tan x times 1 over sin x cos x. And so dy dx. Now, when we simplify here, this is over 1, so the x is the denominator and numerator, so that x cancels there, and that cancels square, so that's 2x tan x. And we have to simplify here, so let's see what we have. Let's see, we have a tan x times here, so let's go up here. Tan x, and we have 1 over, so rather than keep writing that out, I'm just going to simplify here. So tan x is sine x over cos x times 1 over sin x cos x. So because we're multiplying fractions, we can cancel top to bottom. Sine cancels. So we get 1 over cos x times cos x is cos squared x. So that gives us, and we look back at 1 over cos x is the same as secant squared x. So that's x squared. So this simplifies to secant squared x. And without rewriting all this again, I'm just going to go dy dx is the same as y prime, and all of this expression goes down right here without writing it all down and filling up more time. So notice that the two of them are the same. But again, even though we're using logs and we're doing the normal is quicker here. But there are cases, and I'll show you in the next video, when you have to do the derivative by log. And so that's some examples using the logarithmic differentiation. Even though I didn't have to, I had to show you both ways. But in the next video, or a couple of videos after this, we will always use logarithmic differentiation. I'll show you why. So that brings us to the end of this video. And if you like my video, click on the like button, the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content. That's the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video helped you. Bye-bye.